Hello, this is Paul from Foresight Tech. In this lecture, we are going to use the fundamental to evaluate the definite integral. However, we have another version of the fundamental theorem part 2. Okay, so how to find the definite integral of this? Remember, is use fb minus fa, right? What is f? Is antiderivative. Now, for the antiderivative, we have another notation. We call the indefinite integral. So this is just the notation, right? Okay, I will have two examples show you. So how to do calculation. So for the first, so and look at this. We need to find the antiderivative, right? So how to find the antiderivative? So for this one, all we need to do is find the antiderivative. If I use this, antiderivative is this form. This is an antiderivative, right? Remember, we have a formula called the sum formula, right? Antiderivative we can change it to sum of antiderivative, right? So I mean, so you can separate it into two integral. So plus, and then now we see what is this. And this one can find, right? This is what kind of function? This is a power function. So we will have a power, right? The antiderivative of this is a power. The antiderivative of this, what this function? 10 is a base raised to the power. This is an exponential function. Exponential function have another is their exponential, but we need to divide it by ln at 10, right? So for this one, we also know, okay, therefore we are directly defined. So what is this? I put it here. So this the antiderivative is their power. So 10 raised to the 11, right? Remember, then divided by 11. This is the first. So what is this? If we go back to the formulas, their exponential 10 raised to the x power. However, we need to divide it by ln at 10, right? So this is the second. And put this together is the antiderivative of this function. Okay, so that's all we need. So I was going to show here should be do calculations like this. The original question, 10 raised to the x power dx. Okay, we're going to do is like this. We need to find the antiderivative. We already find it. It's easy to find. Okay, so I put it here. This is the fundamental. What is the antiderivative? So the first is 10, x with the 11 over 11. This is the first antiderivative. The antiderivative of the second is this. So 10 raised to the x power over ln at 10. And then I put it here. So what does this mean? From 0 to 1, the difference. This is a fundamental, right? So this is a fundamental. And the inside this is the antiderivative. Okay. And then all we need to do is just plug 1 inside minus plug 0 inside. See what do we have? The first plug 1 is I think 1 over 11, right? Plus 10 raised to the 1 is 10, and then over ln at 10. This is the first. Then minus parenthesis. Put a 0 is 0, right? And the 0 put here is what? Is 1 over ln at 10. See, that's, and then put them together, we will get this. So 1 over 11 plus 9, right? Plus 9 over ln at 10. Okay, so do calculation is not difficult. All we need to do is what? Is find this antiderivative. Okay, so this is the most important. One more example. So we look at this. Evaluate this. The same, look at this function first. Can we look at this function? Look is complicated. Okay, do we have any formula to find the antiderivative of this? No, this is not a basic. This is a trig function, a kind of combination. We have to simplify it first. Okay, we have to simplify it first. How to simplify for this is a separated fraction, which is 1 over cosine square theta, right? Plus cosine square over cosine square is 1. And do one more, so you look at it. So this goes to reciprocal, goes to secant. If someone remember, this is a 1 over cosine is a secant. So square is equal to secant square, and then plus 1. And if someone you can go from the original to here, this is easy than that. Why? Because we have a formula to use. I will put it here. And exactly what we need to do the calculation is the original is there 1 plus cosine square theta d theta. Okay, so we just say we can do the first step. Okay, by simplify, the integral function goes to this function now. Secant square plus 1. Okay, another is the fundamental, right? The fundamental tells us what is the end derivative of, we can find one by one. The end derivative of this is what? Is tangent theta. I mean, this corresponding to tangent theta, right? And for how about the 1? Y goes to theta. Okay, so easy to find the end derivative. Therefore, use the fundamental. This is tangent theta. This is theta, and then the difference between 0 and pi over 4. Pi over 4. This is a fundamental. Okay, this is a fundamental. See, this is the one end derivative we need. Now all you need to do is just do calculation. This plug in is what? The first is tangent at pi over 4 plus pi over 4. This is the first. Minus take 0 is tangent at 0. Okay, plus 0. And now you know how to do calculation, right? After this is 1. This is 0. This is 0. So that's 1 plus. Okay, therefore it's 1 plus pi over 4. And this all. Thank you.